In this video, we're going to begin to start taking a look at the environmental impact of some medicines. And so first off, we're going to take a look at nuclear waste. So nuclear waste is the byproduct of the use of different radioisotopes in medicine. And we have different considerations here because they have varying half-lives. So half-lives is telling us how long it takes to reduce the ionizing radiation by half. And they can be divided into two different categories. We've got low-level waste and high-level waste. So we're going to take a look at each one and sort of see how we can dispose of this different type of waste. So like I said, there are two categories of nuclear waste. So low-level waste means we have low activity. So that means there are not many radioactive nuclei that are decaying each second to produce ionizing radiation. And then they also contain isotopes that usually have short half-lives. So the ionizing radiation is given off for a shorter period of time. High level, on the other hand, has high activity, so lots of radioactive nuclei decaying each second to produce the ionizing radiation, and they have generally longer half-lives. So the ionizing radiation is given off for a longer period of time. Now, low-level waste it includes items that have been contaminated with radioactive material or have been exposed to radioactivity. So it can be things like gloves, protective clothing, tools, syringes, even excrements from patients that have been treated with radioisotopes. And so the disposal strategies are, there are a couple. So first off, they could be stored on site until they've decayed enough to be disposed of in ordinary waste or shipped to a centralized site for more specialized disposal. They could also be incinerated. So this is a dilute and disperse type strategy where you would have to check the ash for activity and then dispose that as appropriately. So this will reduce the volume and also distribute it over a wider area. And then finally, it can be buried underground. And so this visual here is showing you how that waste is buried underground. This is a near-surface disposal strategy, so typically it's done in these vaults that are surrounded by concrete, and they're either concrete containers or vaults, and then this is basically left underground depending on its activity or its half-life. High-level waste, on the other hand, it can be pretty problematic to dispose of this waste. So this includes things like spent fuel rods from nuclear reactors, as well as other materials from nuclear reactors themselves. Can remain very hazardous to humans and other living things for thousands of years. And so the disposal strategies do need to be different. First off, they can be converted to glass, which is a process called vitrification, to make the storage a bit easier. Generally, though, they're first kept in storage pools underwater. Typically, this is for a minimum of 9 months, although sometimes spent fuel rods are stored this way for decades. Once they've been underwater for a certain amount of time, they're moved into dry storage casks that are inside concrete bunkers. So this is an example here of a dry storage cask. It's got thick walls made of both steel and of concrete, and all of the spent or high level waste is stored inside of there. Long-term storage is quite problematic, though, because of the very long half-life as well as the very, very high activity. So that's how we get rid of nuclear waste. There are other types of waste from medicinal products as well. Another big one that we really need to be concerned with is the release of antibiotics into the environment. And so antibiotics can enter the water supply by many routes. First off, incorrect disposal of unwanted medications. So, flushing the rest of your antibiotics down the toilet can lead to eventually getting into our water supply. The other way is through agriculture. So, antibiotics that are given to animals can then end up in animal waste, eventually finding its way into groundwater, rivers, and lakes, which can then end up in our water supply. So, treating the water can remove some of these, but it can still be present in small amounts in the water that we drink. And this can be problematic because it can damage aquatic organisms, but can also result in increased resistance to bacteria to these different antibiotics. So it's really important that we are disposing of antibiotics in appropriate ways so that they are not ending up in our water supply. So that's how we deal with nuclear waste as well as antibiotic waste. That's it for this video. We'll see you in the next one.